So first who will good morning to one and all. First who will summarize the previous class. Uh, Previous class we discussed overall the Unit 2 syllabus. Uh, that means we discussed about the solid state electronic devices. Those are PN junction diode and uh, bipolar junction transistor, MOSFET, that is field effect transistor, FET, diac, triac, and LED, light emitting diode, and the next amplifiers, operational amplifiers, the next filters. That means to reduce the noise. So these are the things we discussed just briefly of Unit 2 syllabus. Then also we discussed about the PN junction diode. That is a P type and N type semiconductor are sandwiched together and forming a junction that is called a diode. The purpose of the diode is it regulates the current or it regulates the voltage. So we discussed about the forward bias and as well as the reverse bias also we discussed. So and also we discussed about the forward and reverse characteristics of diode is also we discussed. Here in the forward bias, the majority carriers are electrons. In the reverse bias, the majority carriers are holes. We discussed that. Now we will discuss about the bipolar junction transistor. And this bipolar junction here, I'm instructing the students, those who are names, so you just rename your name as a roll number. So many members, Nagalakshmi, A. Nagalakshmi, and Banerjee. So better change your name as a roll number. After that, after roll number, just you have to mention your name. No problem. Better put your name first, right? And then next today we will discuss about uh, bipolar junction transistor. Bipolar. It's a bijunction. It's a bipolar junction. That means in the PN junction diode, P type and N type semiconductor sandwich forming only one junction. Whereas here in this bijunction, bipolar junction, that means two junctions in this bipolar junction transistor. Transistor is also nothing but, in other words, we'll discuss the transistor here is nothing but, see here, I will tell. Transistor, that means this tran is nothing but a transfer, resistor, SISTR is nothing but resistor. Means it transfer resistance. The transistor is nothing but the name which way it comes. Here the word TRAN is nothing but transfer. SISTOR is nothing but a resistor. So that means it transfers the resistance. That means from low resistance in the circuit to high resistance. So like that. That means in other words we can say this transistor is nothing but it transfer the current in semiconductor materials. Actually, in the semiconductor materials, partially, that means partially conduction takes place, partially conduction of electrons takes place. But whereas in the transistor, here in the transistor, it transfer the current in the semiconductor materials. So remember this point. Whereas in the case of the diode, it regulates the current. Whereas the transistor, it transfers the current in the semiconductor materials. That means from low to high. That means from low resistance in the to the circuit of the high resistance. The next, what is a transistor? Transistor is a semiconductors which is ability to change from conductor to insulator. That's me here. It is an ability to change. That means from the conduction of the electrons to insulator. What is the meaning of here? What we have to understand from here? See here. Semiconductors, it's an ability to change from conductor to insulator. That means conductor means conduction of free electrons, whereas insulator means there is no flow of current. There is no flow of current. That means, in other words, acts as a dielectric. So this, in other words, actually semiconductor we can say it's partially conduction. But here in this BJT transistor, it in one form it is a full of conduction of electrons, and another form it's a negligible flow of electrons. Negligible flow of electrons. We'll discuss the next slide. It can either allow current or prohibit current flow. That means, what is the meaning of this? This transistor, it can allow current. In other words, we can also say the transistor, it regulates the current simply. It allow the current or it prohibit the current flow. That means completely it acts as an, this semiconductor acts as an insulator, and the semiconductor maybe acts as a conductor in the case of this transistor. It useful as a switch. It is also the transistor, the purpose of the transistor, it can also use as a switch, and also the amplifier also we can use, but also as an amplifier we can also use as an amplifier. That means it amplifies the signal. It amplifies the signal, current signal. And then these can be developed by the Shockley. See here, Shockley and Brighting, Pardin Brighting. This is developed by the Shockley in 1947, this transistor. And this is originally made of germanium material. Here the current transistors are made of doped silicon. Almost all the sensors. These are devices made up of silicon. Doped means impurity, doped silicon. Again, I'm revising. All of you see here. Semiconductor is the ability in this transistor to change from the conduction to the non-conduction. That means conductor, insulator. It can either allow current or it can prohibit the current. That means it can oppose the flow of current completely. That means it allows, but only a negligible amount of current is allows. That means according to our requirement. And also it acts as a switch. And also we can also call it as an amplifier also. All of you know that amplifier means it amplifies the signal. Uh, and that means it making correct. And it is developed by the Shockley, and it is made up of germanium. And this current transistors made up of doped silicon. Actually, this is doped silicon. All sensors and the transducers made up of doped silicon. That means silicon material only. Next, we will go for the next one. Bipolar junction transistor, right? One minute. So here the bipolar junction transistor. The transistor here, it controls the circuit through via injected current. Means here in this a bipolar junction transistor, here in the transistor it consists of three terminals. So one is a collector, another one is base, and another one is emitter, and this is the emitter, right? So these are the three terminals. These are the three terminals. Whereas in the diode only two terminals, but in the transistor three terminal. It is a three terminal device. The name of the three terminals are base. It is nothing but a control, and collector. It is nothing but the source of the current. Means from here only the current passes. And emitter, the destination of the current. Here the current passes and reaches to the emitter. That means base is the control here. All of you remember here. Here in the transistor, three terminals are there. The name of the three terminals are base, collector, and emitter. Here the collector means it is nothing but the source of the current. That means the current flows from the collector. That is current. The current flows from the collector, and then the destination of the current reaches is emitter, and the base is the control element. Control. It is the control. Here in this, if you see clearly, the transistor it controls the uh, current through a circuit. Means what I said, that the diode also it can regulate the current, or it can regulate the voltage, whereas in this transistor also it controls the current through a circuit via an injected current. That is, it behaves like a current controlled resistor. That means it is a transistor. In other words, we can also call it as a resistor. That means this resistor, it controls the current. It controls the current flow, the flow of current. It controls the flow of electrons. This is a NPN junction transistor. See here, if you see here clearly, this is a collector current, right? Current, the IC is the collector current, and collector voltage VC. So when it sends, automatically here this is the base current, and then the flow is occurs in this direction, right? See here, that means from the collector current at the source, and then it reaches to the emitter current. I is the emitter current, and here the base current is there. The base is also, that means here if you, the NPN junction transistor, if you see, this is base is nothing but a p-type semiconductor. Base is p-type semiconductor. So now here in this NPN transistor means, that means either n-type semiconductor or a p-type semiconductor is sandwiched with the opposite pairs. That means, for example, if it is at here p-type semiconductor is there means, so the opposite two types, that means opposite type is n. That means here the n-type is sandwiched. That means n-type. For example, a PNP transistor means, for example, if you say PNP, so PNP means here this is n-type is the base, and then the opposite pairs. It is n is opposite pairs is p, so p-type both. So the transistor can form either a p-type or n-type. P-type, this is p-type or n-type semiconductor sandwich with the opposite pairs. For example, here is n means both are p. For example, here it is a p means both are n, like that. It is sandwich like that for formation of the NPN or PNP transistor. The next, see here in this, it is clearly the voltage of collector emitter is greater than 0, and the voltage of the base emitter is greater than 0. So both the voltages are greater than 0. That means that is a supply voltage. I will show you that is connecting the terminals. The next, this is NPN transistor. If you see clearly in the NPN transistor, some of the members they came, Nanda Kumar and Tarun Raj. Better change your name as a roll number. KK Durga Kalyan Macho. Already we given instructions. Already we given instructions, right? Nanda Kumar, Tarun Raj, KK, and Durga Kalyan Kumar, right? Change your name as a roll number, whether you are there or not. KK, right? Keshava, right? Right? Nanda Kumar, Nanda Kumar, whether you are there or not, you to just unmute yourself and talk to me. Nanda Kumar. Nanda Kumar.
Yes, sir.
Okay, okay. So what I discussed now, Nanda Kumar?
Bipolar transistor.
Huh?
Bipolar transistor.
Bipolar. In the previous slide, what I discussed, can you explain in 2 sentences what you understand? Nanda Kumar,
Yes, sir.
I'm asking you only. Nanda Kumar, your number. right?
321, sir.
Lateral to 321. Okay, right. Very good. You better what I discussed in the last previous slide. ఏం చెప్పానమ్మా? Here, if anybody, if you are not able to follow or understand, just you can ask, sir, I am not able to understand. You can repeat once again, sir. Like that, I will repeat. You are not telling me 321 lateral entry, what I discussed in the previous slide. అమ్మా నందకుమార్ నందకుమార్ మాట్లాడాలి. lateral entry 21. lateral entry 21 లేడమ్మా, నిలిపినట్టున్నాడు. 21 is there 21 lateral entry 21. I'm asking you only, నందకుమార్. Sir, again I'm repeating the, see here in the slide, this again I'm repeating. I will ask any one of you, right? So be cautious. I will ask any one of you. You have to be in time correctly. I will ask any one of the three members of the completion of this. Here the NPN transistor, that means here P type, that means any P type semiconductor or N type semiconductor, right? That is a sandwich with the opposite. Here see, if you see clearly, P type semiconductor, for example, if it is N means N, the P can go for either P type or N type semiconductor is sandwiched with the opposite pairs. Here for P opposite is N. See here N and N. Same similarly, if you take N type semiconductor in the middle, then opposite is a P. Both are P. So this one we can call it as a NPN transistor. This one we can call it as a PNP transistor. This is NPN transistor and this is PNP transistor. Here what I said, this collector in the transistor, we have terminals. Those names are collector, base and emitter. Here the collector is the source of the current. It allow it from here the flow of current takes place, and the base is it controls. Base is it controls the. Whereas the emitter means it whatever the destination of the current. Destination of the current means from the collector the current allows, and then here the base controls, and then the current reaches to the destination, that is emitter. So we can call here, if you see here the collector current, this is IC, the collector current, and then this is the base current, and this is the emitter current. Here this is the emitter current. Means from here the arrow marks clearly it shows that arrow mark, and this is the base current, and lastly the destination is the emitter current. Actually this is used for to control the current. And also see here this one we can also call it as a resistor. That means it controls the current. Here right. Same similarly in the PNP transistor also. Number 388. It is audible to you? My voice. 388. 388 is there or not? Actually he is there. 388 is there. 388. Number 388. Unmute yourself. 388. Already I given permission. 388. Number 388. 388. I'm asking. Actually, he's not there. I'm putting in the waiting room. 388 is there or not? Actually, that is not the correct procedure. See here, just you are log in and then you are not. Is it right attitude? Think 1 second. I'm putting him the 388 in the waiting room. The next 379. You are there? 379. Yes, he is there. Then 379. Unmute yourself. 379. 379. 379.
Sir,
Right.
hello, sir.
Whatever I am talking it. Babu 379. Chepnana.
Sir, I live in hospital, sir.
Okay, you are listening? Okay, right.
Sir,
Very
I
good.
can
Very good.
see.
Your name, Mister?
Yes, sir.
My voice is audible to you?
Audible, sir. But
Okay,
some
okay. Very good. Very.
disconnected to other persons.
ఏమ్మా ఏంటమ్మా
అంటే ఇక్కడ
హలో
sir, I live in hospital. Some distance created to other persons.
ఓకే ఓకే బట్ యు ఆర్ దేర్ యు ఆర్ లిజనింగ్
Yes, sir. I can see,
రైట్
sir.
వెరీ గుడ్ వెరీ గుడ్ వెరీ
Thanks for
గుడ్
listening,
ప్లీజ్
sir.
ఓకే
Okay,
రైట్
sir.
వై యు ఆర్ ఇన్ హాస్పిటల్
Sir, my sister will be pregnancy, sir. No.
రైట్ వెరీ గుడ్ ఓకే 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 బాబు
Okay,
వాట్
sir.
ఈస్ యువర్ నేమ్
Oh, Mastan,
ఓకే
sir.
వాట్ ఈస్ యువర్ నేమ్ ఓకే
Sheikh
ఓకే
Mastan, sir.
ఓకే ఓకే అమ్మా ఓకే 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 మ్యూట్ యువర్ సెల్ఫ్ నౌ నెంబర్ 336 అన్మ్యూట్ యువర్ సెల్ఫ్ 336 రెగ్యులర్ 336 336 right okay 336 you responded just to unmute okay good morning 336 good morning unmute yourself right so your name 336 name I given permissions to you Pranit okay right so what I discussed with you, just to you feel free to talk 36 36 number 36 okay right it is unmuted just to talk I given permissions right okay now you can talk 336 మాట్లాడండి బాబు మీరు పక్కన అన్ని వినపడుతున్నాయి అప్పుడు వినపడుతుందమ్మా వినపడుతుంది
ఓకే సార్
అర్థమవుతుందమ్మా
హలో సార్ హలో
వినపడుతుంది బాబు
ఓకే సార్
యు ఆర్ కమింగ్ రెగ్యులర్లీ టు ద క్లాసెస్
ఎస్ సార్
ఓకే రైట్ ఇప్పుడు నేను చెప్పేది అర్థమవుతుందా మెకాట్రానిక్స్ క్లాసు
ఎస్ సార్
ఫస్ట్ యూనిట్ అంతా అర్థమైందా బాగా యు
సార్
ఫాలోడ్
ఎస్ సార్
ఓకే రైట్ వెరీ గుడ్ right then here if you go for NPN transistor now we will discuss about NPN transistor clearly here in this in the NPN transistor here this P is NPN P is in the middle right and the p-type semiconductor is sandwiched with the opposite p, that is n-type semiconductor. Here what I said in the previous slide, this the voltage, if you see here this is the voltage, right? VC, and here VCE and base emitter here. Are you? It is showing, right? It's clear. Um, Here VCE and VB. So right, this VC and VB is the voltage regulators. If you see here, these are the uh, so these are the here. These are the things, and that means here this is a base. See, this is base, and this is V. This is the collector, right? You can go for emitter or collector. That means I am taking this side is anyone who can take collector and base, and this is base, and this is emitter, right? Can take it. So in this, what here observe here n type. For example, if it is a collector, this collector from this junction. See here, if you see this junction, always this, if it is a collector, then this acts as a forward bias, right? And this junction, this one acts as a reverse bias. This is the reverse bias, and this is the forward bias. So that means here in this this the means this circuit. If you circuit, this circuit is acts as a forward. If it is a collector, this is a collector, and this is a base, and this is emitter. N type is emitter, right? So here this circuit is acting as a forward bias, and this circuit is acting as a reverse bias. So in this forward bias and reverse bias, both are there in the transistor. That is in the PN junction diode, it acts as a if it is a PN or NP, that means that the terminals changes to the positive or negative. It acts as a, for example, forward bias or negative bias. And then, but here in this, a forward bias is there. This is a forward bias, and this is a reverse. See here, the base emitter junction. Base emitter junction is a forward bias, and the base collector junction is anyway. For example, this is a forward bias or a reverse bias. See here, and then next in this, for example, if you take this end is a collector, all of you listen carefully. Just the concept is only 5 minutes only 3 or 4 sentences. Here the collector current, here the collector current, that means flows towards the p type. Means flows towards the p type. That is because it is n type. N type having a free electrons or more electrons. That means from the collector, the electrons flow towards p type. So here that means a collector current, right or wrong? Correct. That is a collector current. Are you understand? So 1 minute, wait. So okay, right here, right, if you take the emitter, right, if you take emitter, right, here in the observations, here if you take this is emitter, same as we can follow emitter, right, and this is base. So under the figure, we can follow this. We can go for opposite direction also. This is emitter base collector. We can go for any, because both are n only, right, and this is collector. Okay, right? Are you understand? So here it is also same. The circuit diagram we can follow like. We can also take this is as a collector, and this is as a base, and this is emitter. Anyway, both are NPN and PNP. So the in the circuit diagram we can take as it is, though for understanding. So here from the emitter, the current flows. This is the acts as a forward bias, and this acts as a reverse bias. If you see here, the emitter, the here this is n-type semiconductor. The electrons are minus are there, right? Here these are the free electrons in n-type semiconductors. The electrons flow takes place towards the p-type semiconductor base. That means here the p-type semiconductor is lightly doped. is lightly doped with a very thin material. So in the base, holes are there. That is holes, small holes. That is positive. This electrons from the N type, only a few of electrons is attracted towards the holes. That forming base current. Base current. That forming base current. All of you listen carefully. Again, I am repeating. Here we are taking this is emitter and this is a base and this is a collector, right? So from the emitter, that means a N-type semiconductor, that means electrons, a flow of electrons towards a P-type, that is a base, towards a base, towards base, and only some of the electrons will attracted towards the holes. That means here the P-type semiconductor is a lightly doped with thin material. That means only 5%. That means only 5% only 5% of emitter current, that is electrons will attracted towards the P type. That means only some of the volume, that means a few of electrons is attracted towards holes in the P type base and forming base current IB. So and then next the remaining 95% of electrons is crosses towards the collector, that is N type. Here 95% is crosses. That means from the emitter current, 95% of electrons crosses towards the N type. That means collector. That means it collects the current. That means total 95%. That means total the emitter current is nothing but IE current is nothing but emitter current is nothing but it is the sum of the base current and the collector current. See here again I'm repeating. All of you listen here. This is again I'm repeating. All of you see here. This is the concept you have to understand clearly. This is emitter and this is a base. This P is a base and this is collector. Right? Here it is very difficult to write. No, no. Okay, right. The emitter base collector, right? Here this N and P are sandwiched and P and N are sandwiched. Here from this N type is all are electrons. These are all completely electrons. N type semiconductor and P is holes. So here this is lightly doped. If you see the P type is lightly doped with very thin material. From the emitter, the current that means flow of electrons takes place. Emitter current it is emitter current. The flow of electrons takes place, and here the P type is lightly doped. It is the flow of electrons towards P type, that is in this direction, and here this is P type is lightly doped. That means thin material. That means electrons are only 5% of electrons from the emitter current is attracted towards base. That means forming base current. You understand? Forming base current, IB. Forming base. And the remaining 95% of electrons from the emitter is crosses towards N type. Here in the collector, this collector collects the flow of electrons, forming collector current. That means 95% of emitter current is the collector current. That means here the emitter current is nothing but it is a sum of the base current and collector current. If you see it here, see here in this, if you see here, this is emitter current. Here, if you see, this is the emitter current is the sum of the base current and collector. Here in NPN transistor, the majority carriers are electrons. Remember this point. Majority carriers are electrons. That means from this side, that means from N type, that means emitter current, the current flows towards P and N. Here P is lightly doped. Only 5% of electrons is attracted towards P type, and 95% of electrons is attracted towards N type. So, are you understand this concept? This is used for current regulation only. Are you understand? Correct. Are you understand? And then we can also reverse case. This is emitter we can take, or and this is base, and then we can collect. But here in the circuit it is mentioned, so that's why we are taking like that only. And if you reverse also we can take. Means this is collector and this is base. This is for example emitter, base, collector. Right. That means NPN only. That means both are N and L, right? But here some annotation. This is diagrams will change. This connections will change. The next we'll go for the next one, and PNP transistor. Only 5 minutes it will take. This is also same procedure. See here, this is a emitter. See here in this, if you see clearly in the PNP transistor, here N type is sandwiched with the opposite way, that is a P type. N type is sandwiched with P type, right? Both P type. And same similarly here also the emitter current. Here from this emitter current, right? The flow, if you see clearly, this is the emitter current, and then the base current, and then we can get the collector current, right? Here the collector current. Then if you see clearly, here this is both are less. If you see, if you observe clearly, this both are less than 0. I will tell you. Right. The PNP junction transistor, this is acts as a same similarly forward bias. Here the terminals are changed here. What I said now, the terminals are changed. In the previous case, this is like this in the NPN, right? In the both our cases, it is like this, right? But here in the PNP, the changes, circuit diagram changes. So yesterday I informed to you, while connecting the circuit diagrams, we have to mention anode, cathode, plus minus correct indication. Otherwise, the drawing completely wrong. Remember this point. You have to remember it while drawing in the examination. Also, you have to practice it more and more. And then, if you see here in this case, and this is a emitter, right? This is emitter. I'm taking this is emitter, right? And this is base, right? This is base, and this is collector, right? And this is collector. See here, same similarly here in the emitter, the current flows towards N type. Here the emitter, that is P type, the current flows towards the N type. That means here, here the current is there, that is a negligible current, is that is holes completely, P type is holes. So that's why it is a less than 0. So that's why it's a less than 0, right? So that means a negligible amount of current from the emitter of P type is flowing towards a N type base. N type base. This is a base. This is base. This junction is base. And then the remaining 95% of the holes is crossing towards collector, and then here forming collector current. The collector current here, it is all it is flowing is holes here, whereas in the case of the NPN transistor, the flow of electrons is electrons. Here the flow is occurring takes place holes. Here the holes are flowing. Here the holes from the emitter P type, the holes are flowing towards N type. Only 95% of holes is attracted towards electron in base. That is N type base. That means only 5% of holes from the emitter, that is a P type, is attracted towards N type. Why? Because it is a lightly doped or thin dope. And then the remaining 95% of holes from the emitter P type is transferred towards the P type collector, 95%. That means here it allows a negligible current, that is less than 0 both the voltages. Means here that means here the voltage. this is the here the voltage connected, right? That means this is used for maybe the current supply very less. That means holes are transferring. That is a very negligible current in terms of maybe milliamperes or microamperes. Very negligible. So where the negligible amount, that means where milliamperes of current has to pass to some component to function that where that in that particular area we can go for use this PNP transistor. Are you understanding? Here, this all of you listen carefully. This PNP transistor is used for very current where the current required very less. That means in the terms of milliamperes or milliamperes means I think all of you 10 to the power of 3. Micro means 10 to the power of minus 6 amperes. It is very less to function that particular component. So there we can go for PNP transistor. We can use PNP transistor. That means here the majority carriers are holes in this. These are the holes. The emitter current is nothing but the holes are flowing towards N type, and some of the holes is attracted towards the electrons in N type and forming uh, the that means forming base current is forming, and the remaining 95% of the holes from the emitter of P type is crossing towards this P type collector. It's collecting. That means forming collector current. Same similarly here in this case also, IE is equal to IB plus IC. That means the emitter current is nothing but sum of the base current plus and collector current. That means here the holes, the majority carriers are holes. In the previous, the majority carriers are electrons. In NPN, the majority carriers are electrons, whereas in this case, the majority carriers are holes. Now, any questions? Anybody? Any questions? Any questions? You can post. Any questions you can post. Or you can ask. Or do you understand this NPN and PNP transistor? This is the transistors. This is, if you see the transistors, different transistors, shape of the transistor. Any? Or you understand? Number 380. 380. Right. And number 4. 4. Number 4. Regular 4. I'm asking about regular 4. You immediately respond. If you are not asked 318, then he responded immediately. And number 304, you are not responded. So what I understand, in which way I can understand whether you are there or not. Number 304, regular. I hope so. You are not there. This is not correct. And 301, 301. Understand? Okay, now respond your attendance. Number 315, 315, 15. 315, 315, 15. Hurry. 315, hurry. Respond. Are you understand? Today's topic, NPN and PNP transistor. Okay. Now respond your attendance one by one. Okay, right. 301. Right. And 304. 4. 5. 6. 7. 7. 8. 9. 10. Respond your attendance. 10. 13. 11. Okay. 13. 13. 13. Okay. 14. 15. 16. 17. 17. 18. Right. Present. 19. Right. 20. 21. 22. Right. Present. 23. 24. 25. 26. 26. 27. 27. 28. 29. 30. 31. 32. 33. 35. 35. 36. Right. 37. 38. 39. 40. 41. 42. 43. 44. 45. 46. 48. 48. 49. 50. 50. 50. 52. 52. 53. 54. 55. 56. 60. 60. Right. 61. Right. Present. 63. 64. 65. 66. 66. Right. 67. Present. 68. 69. 70. 70. 70. Right. 70. 74. 75. 76. 76. Okay. 68. Present. 76. Option. 77. Present. Okay. 78. 78. 79. 80. 80. Right. 81. Present. 81. 83. 84. 85. 85. 86. 88. 88. 88. I'm asking about 88. 89. 90. 91. 92. 92. Lateral entry 1. 2. 2. Lateral entry 2. 3. 3. Lateral entry 3. 4. 5. 6. 8. 9. 9. Right. 10. 11. 12. 13. 14, 14, lateral entry 14, lateral entry 14 option, right. 15, 16, 16, 16, okay, 15 present, 16, 17, right, present, 18, 20, 21, 23, 23, 24, 25, 26, 27, 28 present, right, 29, 29, 30, 31, 31, 32, 33, 34, 35, 36, right, present, 36 present, right, 37 present, 38, 39, 40, 40, 40, 41, 43. Here the option is just I am reading out. All of you see here. Number 7, 13, 14, 17, 24, 25, 26, 27, 48, 52, 66, 69, 88, lateral entry 3, 88%, 3, 16, lateral entry 16, absent is. Lateral entry 3, 16, right, 16%, 23, 24, 24, 27, 29, 32, 34, 35, 38, 40, 41. These are the lateral entries. Again, I'm repeating, all of you will see here. Number regular 7, 13, 14, 17, 24, 25, 26, 27, 48, 52, 69. Number 16 lateral entry. Okay, 16 lateral entry present. So again, I'm signals problem number 16 lateral entry. Okay. Again, I'm repeating, all of you see here. The option is 7, 13, 14, 17, 24, 25, 26, 27, 48, 52, 69. Lateral entries 3, 23, 24, 27, 29, 32, 34, 35, 40, 41. Correct, clear? Now we can end the class. Number 52 and 17. Okay. Today's opportunities are 19 members are absent today. Okay. Okay, we will end the class.